Good day, students. Today we're going to look at a couple of more solutions to your practice exercises. This comes from your factoring chapter, and this deals specifically with the difference of squares, type of factoring. And it comes from page 95 in chapter 7 of your book 3 in your ma1025 booklets. And it just says factor each difference of squares, and it gives us two, we picked two here, E and F, so let's have a look. Now, difference of squares, before we move on to these particular, let me quick review that. If you have any two perfect squares, a squared minus b squared. Now, difference implies that it must be subtract, right? You cannot do the sum of two squares, right? Only the difference. And you notice these are both difference questions, right? So we're dealing with the difference of two squares. Now, you'll notice when we factor these, the pattern. So it's a pattern type factoring. We get a minus b, a plus b, exact same factors. And just to verify that, we'll multiply it out. A squared first, outside ab, inside minus ab, and last minus b squared. And you'll notice the two middle terms will cancel every time you have this pattern, bringing you back to this. Now, A means it's a perfect square. So any perfect square. So if I had something like 9x squared minus 25, are they perfect squares? In other words, can we write this as a perfect square, something squared minus something squared? And the question is yes, we can write it as 3x all squared and 5 all squared. So the 3x becomes your A. That's A. So you can have more than one thing as A. Whatever is squared is A. Whatever is squared here is B. So the pattern would be then A squared minus B squared would become A, 3x, minus B, 5, and then A, 3x, plus B, which is 5. So that's the pattern. It's pattern factoring, and it works every time. However, it helps you to rewrite them as perfect squares. Is this a perfect square? 16x squared? Absolutely. 4 is a perfect square. 16 is a perfect square. It's 4 squared. But rather than write it 4 squared x squared, we don't want to write it like that. We want to write it as what is the whole thing squared. In other words, it's 4x all squared. Minus, and of course the 49 will become 7y all squared. So remember, this is A, this is B. Okay, so your pattern factoring simply becomes 4x subtract 7y and 4x plus 7y. Exact same factors, plus in one, minus in the other. And the order for plus and minus doesn't make any difference. I could put plus in the first one and minus in the second one. Makes no difference. Okay, one is plus, one is minus. So there's the answer to that one. Same idea now. You want to write it as a perfect square. So what is this as a perfect square? Well, 16 would be 4. X squared would be x. Y to the 4 would be y squared. Then all squared. Because if you square 4, you get 16. You square x, you get x squared. You square x, y squared, you get y to the 4. So that's what A is. Minus, and this one becomes what? Would be 7z, right? All squared. So remember, you have to treat this whole thing as A. This is A, and this is B. And the pattern A squared minus B squared. Remember, it's A minus B, A plus B, or A plus B, A minus B. So what's A in this case? A is 4xy squared. Right? So that goes in each one. 4xy squared minus 7z plus 7z. And again, just to tell you the order doesn't matter, I'll switch them this time. Okay, we'll say plus first and then minus. So it doesn't matter. Exact same factors, plus in one, minus in the other will be, and it only works with the difference of two squares. It doesn't work for the sum of two squares. Okay, so hopefully that helps you. That's it for now.